Okay, everyone, so the first step in projecting population is multiplying the whole population that you start with, the initial population, this whole row, by the whole column of birth rates. And after you've done that, you should have gotten numbers that look like this. Okay, and they go in the new members row, because those are all the new births. That's what they are. So now we're going to total that. So add up 0 plus 2.7 plus 10.4 plus 3.5 plus 0 plus 0. We get 16.6. Okay? Now, what that means is, in total, through the first cycle of population, on average, 16.6 new rats will be born across the whole population. They're giving birth to 16.6 new rats. Okay? Now for a little bit of a tricky part, but not too bad. What you do is you take this number right here and you transfer it into this box right here. Okay? Because the total number of new members in any cycle, all the newborn rats that are coming into the population, are now the 0 to 3 month survivors, is what they are. So they're born on day 1, and then they go into the first age grouping as they're technically now survivors in the first age grouping. Okay, so you always take that number and transfer it to the next row in the first box. Now, to get the rest of this surviving members row, you take the original population. Let's just erase all this. You take the original population again. We've already calculated how many of these rats are giving birth. Now we have to calculate, okay, of these rats, how many are staying alive? Because giving birth and staying alive yourself are two totally separate variables. So we have to multiply this whole row now by the survival rates. That'll tell us how many of these rats are actually surviving and making it into the next age grouping. So of these 15 0 to 3 month old rats, they survive at a rate of 0.6. So 15 times 0.6 is 9. That means of those 15 baby rats, the 0 to 3 month olds, 9 of them will survive and make it into the next age grouping. So that 9 goes right here in this box. So of those 0 to 3 month olds, those 15, 9 of them will basically graduate. They're graduating into the next column, the next 3 to 6 month old age grouping. And you go all the way down the line. 9 times 0.9 is the next one. 9 times 0.9 is 8.1. So of these 9 right here, they'll survive at a rate of 0.9%, which is 90%. So 8.1 of them will basically survive and make it to the next group. And then you go all the way down the line and you keep multiplying. 13 times 0.9 is 11.7. 5 times 0.8 is 4. And then you'll notice at the very end, 0 times 0.6 is 0. And then at the last column, the survival rate is always 0. No one survives at the end. They don't give birth and they don't survive. Everyone dies off at the 15, 18th month age grouping. I guess this is implying that the average lifespan of a rat is 18 months, which is a year and a half. So finally, we total all those numbers up in the surviving row. 16.6 plus 9 plus 8.1 plus 11.7 plus 4. We get 49.4. All right. Oh, in this box put down below, the total of the new members row must always be transferred to the first entry of the surviving members row. That's the step we did with this arrow right here. The 16.6 moves into the beginning of the next row. These are the total new members being born into the next cycle. And that is one cycle of female rat populations projected into the future.